to emphasize here that it's myself and Brett Schulte. Thanks, Brett. I appreciate that. And I emphasize that because this is joint work as part of a student-faculty research project spanning currently 2 years. And I think there's a reason that the name is student-faculty research, because it is really student-motivated and student-driven. And so I'm there for guidance, I'm there to help with writing the proposals, but we are working on this together. And so I'm going to talk a little bit more about that on the next slide. You can see all 5 of the names there. And counter to the organization on this slide, I am more organized later on, but we're actually going to work backwards here. So I do want to start with acknowledgments because it talks a little bit about the motivation for this project. And as I said, I've been with the Department of Mathematics for my 14th year now. And we have a fabulous undergraduate research program which sponsors our students for internal grants. And Brett's been part of that now for his 2nd year. Northwoods League is acknowledged here and referenced because they have provided us written permission for using their data for academic purposes. And then to the motivation for this project. So a lot of the material you'll see in here comes from the work that Brett and Hunter did last academic year, including data compilation, the work with the computational tools, and in fact, big parts of the slides on this presentation. And going back even further to last summer, Hunter and I, Hunter was an advisee starting out his freshman year, and he and I came to this analytics conference because of his very specific expressed interest in sports analytics. And so on the way here, drive here, because we traveled to the conference together, we talked about his favorite topic, which is baseball. I'm going to be upfront here. I know almost nothing about baseball. Okay, so you can all happily correct me if I make a flub in that respect. Thanks to Hunter, I have a nice little glossary here because one of the contributions that Hunter made to our research was to put together a glossary on our Google Drive. And it's in very small print, but I may be able to answer your question on what something represents based on his glossary. So we went to the conference, and on our drive back, we basically put together this research proposal. So we started off with what was initially kind of a 2-pronged approach. And so the 2-pronged approach was a team approach, and then somewhere between these 2 branches was individual player approach, working eventually towards an end goal. Now you notice that there are way too many intertwinings and pathways. Again, starting off with a plan, there are pieces throughout this that the students actually devise themselves. I came back to one of our research meetings one week, and the students came in, Brett and Hunter said, yeah, we've been talking about this idea called chunks, and we have a definition all set, and here's what we're doing with it. Fantastic. Never would have come up with that idea myself. We'll get to a definition of how they represented that a little bit further down the road. So what I'd like to point out here is the lighter stuff is the stuff that we've already gone through, and then the darker shaded stuff is the plan for this coming year. And then there's probably some bubbles over here and down here that I haven't filled in, but that's enough as it is. So let's go on to the next thing. Oh yes, and I think my students would probably argue that this is a much better representation of what they actually had to do. If you go back and forth between that, that kind of took over a lot of our work this last year. And so I'm going to talk a decent amount on the organization and work with the data, as well as a little bit about the development of the measures and the tools that we used. Okay. So we had, trying to get away from that really vague, wobbly picture and come up with the 3 questions that we wound up focusing on last year. We talked about strength of schedule for 20 players in a local collegiate league called the Northwoods League. And we wanted to use their strengths of schedules, that is who they played against, to predict playoffs. And we talked a little bit about those chunks of games, and then we also talked about some updated statistics. So I'm going to go through each of those in order depending on the amount of time that I have. The first one, and I'm really glad that I think Dr. Retzer brought this up, talking about starting off with a visual. And this is something that we put together to try and represent the playoff finale. So the teams that wound up making it to the playoffs, unsurprisingly, are represented highly in the ending winning percentages. But you can kind of see that their pathways go all over the place. We have a few. Now, of course, we're going to have more variable winning percentages across the first few games. But you can see at least one of them kind of took a very different pathway here than the others. That will come up. What we're going to do in terms of looking at a predictive model is to try and predict some information that wasn't used to fit the model. Again, like a quote directly from Dr. Retzer, that we don't want to predict data that was used to fit the model. And so our idea was, well, let's take the strength of our records as measured across the regular season, which happens over summer, and then use that to predict the playoff head-to-head competitions. All right, and I promise this will be the most math that you'll have to deal with in this. We're going to talk a little bit of notation. The W is pretty obvious. That is the number of wins for a team I. And some of my students that I have right now really don't like subscripts. Subscripts just refer to repeated observations throughout some list. And so the I refers to the different teams that we're going to be looking through. So I equals 1 up to 20. All right, so the other thing that we're going to be talking about is this pi sub I. Hopefully everyone has seen a pi before. That pi is a constant, but it's going to be something that's a constant updated. Now you might have heard of Bradley-Terry ratings, or I initially learned them as Kroc ratings, and when we had our research discussions, we just couldn't get away from that phrase. But they're really based on the initial model posed by Bradley-Terry. And so we're going to refer to them as Bradley-Terry. If you haven't heard of them, no problem. We'll talk about them on the next page. And the whole purpose is to calculate the probability of winning a game at some point in time. And here we're taking a point in time as a game across the season of, I think it was 718. I've got that on a slide somewhere, but the 718 games throughout the summer season. Now, of course, those 718 games are scattered across the 20 teams, but with head-to-head competitions. And so, when we talk about a head-to-head competition, we're talking about I versus J. So team I versus J. In our league, a lot of the teams were from Wisconsin, we're from Eau Claire, and Eau Claire Express was one of the teams. They would occasionally play Madison. I don't remember the Madison team's name, but it was the Eau Claire Express against some Madison team. And so the NIJ refers to the number of games that they've played together. And we're going to take the current state, so to speak, if you're a Bayesian, this is kind of like a Bayesian update, We're going to take the current state for each team across all comparisons, and then talk about an updated constant pi I at the next time, or in the next game point. All right. In order to handle this, we had to start someplace. So we started with an even split. So that means we assumed that each team had played each other twice and won once. All right. So then, once we iterate across our total of 718 games and do this recursive update, that's what this thing is called. And by the way, we did not work this out by hand. That would have been ridiculous. We used a nice little function in R. Again, if you attended Dr. Retzer's talk, he was going through a lot of our code. I'm not going to make you sit through much of that. I will have a couple slides that have a piece of our code here or there. All right. The end goal is to get the odds of Team I beating Team J. That's really all we're trying to get to. So, we use this fun little package, but in order to use this fun little package, we had to get our data into appropriate format. And this is where, and this whole next section is really Brett's section. This is what he was working on primarily, especially in the fall semester last year. And that was keeping track of game scores, so scores for the different games throughout the season. We kept track of the game orders, dates, and some other important information that we thought we might need to keep track of. And as always, there are going to be things you don't expect, like dates that show up as weird numerical representations in the tools that we're using. And yeah, so we had to work through that. Brett did a fantastic job sifting through all that information, and I promise not to say Brett too much, so. But this really is, this is his work. So I'm going to focus on the intermediary steps. So we started off in Excel, transitioned to run things through R, because we knew that we were going to need things in R in order to run the Bradley-Terry package, which saves us a lot of headaches in terms of computation. So the vast majority of the team compilation to get cumulative win-loss records happen there. And there is one more step. We had to run this through R code to compute binomial count summary. Basically, it's just another way of making sure we could use this particular package. So, data setup, super boring if you saw Chris Malone's talk though. That really is a huge chunk of what we do. And even if you're nodding off during this, you will make your life much easier if you spend time here. And so we did. We spent a lot of time here. And we used this, finally. We'll get some results here. But I'm going to talk a little bit about the playoff bracket. So this is the thing that we were trying to predict. We came out of those 718 games. We had Bradley-Terry constants. And we were going to use those to predict at each branching which team would win. And of course, we knew the answer. But we only used information from prior to this point to make the predictions. All right. So, a couple things to keep in mind here, and it will turn out that context is really important. I don't know if you can see this at the top here, but first thing to notice is that these are all single game bracket splits up until the final here. And I know my best friend was watching the Brewers game and updating me as it was the last Brewers game, sadly. And I was just listening to a 538 podcast on the way down. It was the one I could stay awake to. And they did the Hot Takedown podcast. And they were doing a really, a bit more of a look at the fact that this is a really dumb way to handle things with the wild card and in this case, dumb is maybe a strong word, but it is not going to give us the best representation. And so, well, not us to judge, so that's what they did. We'll take a single game and see what we can figure out with that. There's also something to keep in mind here is that there are 2 divisions within the league. Okay? I'll come back to that and talk a little bit more about that. Anything else I wanted to comment on here? One other contextual comment is that this is a collegiate baseball league. That will matter. The games schedule, those 718 games, lasted only between May and early August. One thing that I found, again, very impressive with the attention to detail is noting that almost all the games followed day to day. The researchers picked out the very one small span of days in there where there really weren't any games. So there were no games in this very short span. Otherwise, it was almost every day. Every once in a while, they got a 1-day break. I think there was another 2-day break in there someplace. But it was nonstop. So this is a very intense season. All right. Here's what we figured out. All right, so a head-to-head matchup. The actual winner, here's what we predicted. So A stands for away, H stands for home. Hopefully that's pretty typical notation. We didn't match on the first game. Okay, so we went and took a look at the second game. Oh, good, we got that one. You notice there's a lot of red up there. If you count, we only got 2 out of 8. We did worse than guessing. And I can tell you as a teacher, it's really depressing to see that. As a researcher, it's even more depressing to see that. All right, so, okay. So I'm going to focus on the fact that we did this across all teams for the entire season, up to, but not including the playoffs. Next thought we had was, well, maybe it really doesn't matter. Oh, 20, yeah, there we go. Horrible number, yeah. So next thing we took a look at is, well, maybe it doesn't matter who else they played, but only how they did against the teams throughout, the teams that made it to the playoffs throughout the season. Still worse than guessing. All right. Now, if you might want to make a comment about running multiple tests and type 1 and type 2 errors, and I absolutely 100% agree with you, but there are some observations that I think we can take away from this. So the next thing we took a look at were Bradley Terry ratings after the midsummer break. Slightly more favorable. Again, could it be just an artifact of looking at multiple tests? Yes, but better than guessing. Hurrah! All right, and then we took a look at 150 games before the playoffs, 77.8%. All right. Well, I'd like to bring back this picture. There's a couple things I'm going to note here, and the first thing I'm going to note is this vertical line, which is about 100, it's the mid-season break, I should say. Yes, that's the mid-season break, and 150 games back is right around there. So what do we notice in the patterns? Well, I guess I would say that this team, I don't remember who this team is, but they're the most dramatic aspect of it. We notice, obviously, we probably don't really care until after about 100 games, but we noticed they were not doing great at first, and then they got better and really kept getting better. What's going on here? Well, community input. So when we talked about these results at the presentation, the students had several community members come up and talk through the fact that, oh, didn't you all know that the teams change up about halfway through the season when the college, the players who are playing for their college teams come in and join the team, and it totally changes up the actual composition of the team. Well, obviously, if there are different players playing, the results are going to be different. And we also found out something about the playoffs, which is perhaps a good reason to not actually predict the playoffs, and that is many of those same players actually have to return to their colleges before the playoffs actually happen. So some really sharp changes into what the team composition actually is. So realistically, we cannot do a good prediction here with only this head-to-head comparison. We have to integrate some sort of information about the individual players because the individual players change dramatically. Or we just never predict playoffs and we'll never know. But we'd like to be able to predict playoffs. Okay. So I'm just gonna make a quick comment here because I do want to really acknowledge, I acknowledged this a little bit already, but I do want to acknowledge the idea of coming up with different approaches. So one of the things that the students came up with was this idea of chunks. And effectively, they did an observational study and just got some basic trends, averages across the team during these chunk times, comparing these chunk times to the season times, just trying to take a look at what were the most important features to a team's success during a chunk of time or failure during a chunk of time. Or win versus loss. I don't know if success versus failure, but win versus loss is a better emphasis there. Again, this suggests that we need to integrate the individual player effects so that we can try and pin down those contributions a little bit more. All right, so how did we do this? So we wanted to take a look at some of the new measures because newer measures are intended to be more accurate. And so one of these is what's known as FIP and fielding independent percentage. Yes?
Pitching.
Fielding independent pitching, thank you. Fielding independent pitching. And in theory, it eliminates the variability formulas. We're not going to talk about those too much because we use computational tools. These are really simple computations at their heart, but we have to do this for a lot of data. So we're not going to sit there and, well, we can use a spreadsheet if it's organized in a very clear fashion, but as it turns out, that can be a little bit unwieldy to pass along to someone else who might want to use the same thing, as we've found out already this year. And I just am going to mention that we did indeed find that FIP was less variable. What's important here, though, is does that matter that it's less variable? Is it actually a better predictor? Again, is that a better predictor of the utility of the pitcher, if you will? So I'll skip through another formula and mention that our end goal is to compute something along the lines of wins above replacement. That I know I have right because I put it there at the top of the page, so I remember. Each of these subcategories has its own little calculational formula, many of which are nonlinear. All right. So we did, actually Hunter did a very thorough analysis and breakdown of this components, put together a document, and we determined that constants are determined for MLB setting. That's not necessarily prohibitive. I mean, we can go in and do some modeling and come up with our own appropriate constants, but what is prohibitive is the inputs that come from video tracking software. So we have to be realistic here. We cannot do wins above replacement without the requisite information, and probably are not going to convince Northwoods League to get video tracking software just for our study. So this year, we are continuing on with this analysis, and we're trying to do things a little bit more with reproducible methods. So as I said, that spreadsheet works. It's a good way of organizing the information, especially for a person who is just learning R. Hunter had never worked with R before, and that was his assigned task. So he did the best thing that he could, and eventually later on in the year he did a 200-page or 200-line code compilation of various pitching information. So he definitely integrated things, but at the time that this was put together, didn't have that. So what we are doing now, and Brett is currently part of this team, we want to focus on better ways to compute those statistics, that is, ways that are just a little bit more fine-tuned. I'll go back a slide because I want to mention we don't necessarily need to reinvent the wheel here. There are people who have thought of this already, and I say this because I thought of this as I was walking to school one day, and I said, hey, what do you all think about trying to put together a package that does these kinds of computations? And then another week later, I wonder if someone's already thought of that. And of course, they have. But we've also realized that the vast majority of them are for Major League Baseball computations. And so we're going to examine a little bit more of the open source, that is, in flux packages that we might be able to contribute and add our own say on those. All right, so this is our final goal, and I'm going to jump to, oh no, I'm going to comment on this briefly because I have to. I feel it very important to comment on the fact that we have to make sure if we are integrating individual player data that there is benefit to it. So if we're just working with team records, and all this data is publicly available, but if we're just working with team records, that is a larger space to take a look at. If we are talking about individual player data, we have to be very careful that we are doing something of benefit to the community, to the league, and you know, obviously we'd like to do something that adds to knowledge. All right, so we have gone through that process and started our documentation, which is an improvement on that. And we're moving forward with two different ideas. I won't go into a lot of detail on these because I don't have a lot of detail to share with you. But I'm going to talk a little bit about computing a war-type measure. Again, that has to do, we have to deal with a nonlinear model there, so we do have tools for addressing that. And then we have some ways of connecting that with the head-to-head competition. Or we could alternatively try and use some more quantitative measures that have to be consistently measurable across teams. And I say that because going back to the war statistic, the way it's generally used is not to produce a number that can be thought of as on a number line, but more as a categorization. So we want to make sure that we're utilizing the data in the way it's intended to be utilized. And future thoughts, you probably don't care about that too much. So a few references there. I really appreciate you sticking with me through that, and I'm going to invite Brett up here to join me for questions if you have any.
Might be able to answer a few of the more technical questions, maybe.
I really got into my teacher voice there, so hopefully no one lost their hearing. Sometimes I do that.
So you built all this out after the season was played? Is that?
Yes.
But you collected the data during the season?
No, we don't.
Okay. So then you're gonna. The idea is then you're gonna come up with a war type.
Yes.
Number for next year.
We're trying to make we're trying to compute something that can be used for the future and that can be iteratively updated each game, so that each player has its own value, and then hopefully that can be computed to calculate if you think they'll win or not in their next game. That makes sense.
So you're gonna use their college statistics for each individual
We're
player?
only using Northwoods League statistics because it only matters to us it only matters what they're doing in the Northwoods League.
Yeah, but they only typically play 1 or 2 seasons in that league, don't they?
That's true, and that's why we want to find the statistic and have it update each game so that it'll be easier to predict each game because there is such a high turnover of players in the league.
So when will that be, how far into the season will that be reliable? Like, you know what I mean?
I would probably say, you're right, it'll only be reliable after a given number of games, and we're not sure of that yet because we don't even have, we haven't actually made a model for all of this yet. And I thought of that too, and we'll have to find that out as we do more work on this.
Does your bookie take bets or something on the Northwoods League or something?
That's why we're very clear about academic purposes.
Are you guys working with the league at all, or any of the teams? Have you guys talked to them?
I believe you've talked to them.
Yep.
You finally actually went there and they talked to you and they didn't respond to any calls or emails, so.
Well, the league itself did. I called and the league itself was very responsive and gave us specific written permission for use of their data. The Eau Claire Express, now I'm going to give them a lot of grace here because when I happened to drop into their office, they were on their way to their second to last playoff game. The team manager was gracious enough to give me 10 minutes as he was heading out the door towards the bus. So I did follow up with an email. I'd very much like to hear back and collaborate with them. And I've certainly opened it up to the league itself that within the next few months, if they have a question